So that's coal, petroleum, and natural gas. And I put a little dotted line there to just show for you to see that the sun, that's captured the sun's energy as well. It's just that it's been sitting in the ground for a long time. And because most of this coal comes from what were called coal-forming swamps around 300 million years ago in a period called the Carboniferous. I'll show you when that was in a minute. Okay? But we don't have coal swamps anymore. So we could, if the climate gets hot enough and the earth turns into gigantic swamplands again, another couple 100 million years we could form coal again, but we're not. These are non-renewable. Petroleum deposits come from mostly plankton that's settled out from oceans and formed various deposits either in large lakes or in the ocean, and that slowly become compacted into petroleum. And natural gas is sort of associated with both of them. Another one that you might not think of, what's hydropower? Hydroelectric power. Water. How does that work?
Dams, rivers.
You have a dam in a river, okay, and a lake forms behind the river, and then as the river flows through the dam, you turn a turbine and you generate electricity from it. How does the water get up behind the dam?
Rain.
Rain. And where does the rain come from?
Lake.
The lake, or probably more like the ocean. Okay, so rain gets into the sky because water evaporates off the surface of the earth. What's causing it to evaporate?
Heat from the sun.
The heat from the sun. So hydroelectric power, if the sun stopped shining, the water would stop moving around the planet. So hydroelectric is still a manifestation of solar power. And that's renewable. The other one that has something to do with the wind, but not completely. Anybody want to guess?
Geothermal.
No. Tidal wind. Some of the energy of the wind comes from the sun. Give you an example. How many of you go out to the beach in the summertime? Any beachgoers go to the beach in the summer? Which way, if you're on the beach, usually where's the wind coming from when you're on the beach during the day?
Ocean.
Comes from the ocean, right? It's pulling up from the ocean. The reason it does that, so let's say you're out on the Outer Banks. So Outer Banks, there's a cross-section of the Outer Banks. Here's the Atlantic Ocean. Here's the Sound behind there. Okay, you got the sun shining on the land, and you got the sun shining on the water. What would you rather do? Put your hand in a pot of water and put it on the stove, or put your hand directly on the stove?
The water.
Water. Why?
Because it holds back some of the heat.
It takes a while for the water to heat up, to be hot, but if you just put your hand direct, so heat that goes directly onto a solid surface heats up much faster than heat that goes into water. So it takes longer to heat water up. So what happens when something heats up? What happens to air when it heats up? It goes upward. So you have the same amount of heat coming from the sun, heating up the water and heating up the land, but what's going to heat up faster? The land. And therefore you have heat rising off of the land, and where does that get pulled in from? It gets pulled in from the ocean. So a lot of and that's wind. Anytime you have air moving across the surface of the land, that's wind. Okay. So solar energy also is used to produce wind energy. Not completely, because a rotating planet with an atmosphere has what's called a Coriolis effect. So when you have an atmosphere, just the spinning of that Earth creates various vortices and spinning patterns of, so that's why I do a dotted line, because some wind actually comes from the rotation of the planet. Look at Jupiter, for example. Jupiter has these large swirling storms on it. But nonetheless, since we think the planet rotation is slowing down a little bit, but it's very imperceptible for all time that we will know, the planet will still be rotating, and the sun should still be shining, and therefore wind is considered renewable. So pretty much those are the major, all the major energies that are in some way related to the sun. Isn't that easier to remember? Biomass, and then the three fossil fuels, and then hydroelectric and wind, and now you know why. So let's go ahead and put nuclear over here. And geothermal. Geothermal, there are nuclear reactions occurring in the Earth, and they generate heat. So you want to stay warm, go down.
Is that from the core? They were saying?
Not quite from the core, but from around the core. Those reactions are hot enough to melt rock. You know, the Earth is nothing but like a gigantic iced tea drink. The heaviest stuff is at the bottom. So we think the Earth has a solid iron core. Iron is heavy, so it sinks to the bottom. And all the lighter you get lighter as you get to the top. So all the rocks, which we consider hard, those are actually lighter than what you have at the center of the Earth. So it's like the froth floating on the surface, called the lithosphere. But there's a lot of heat in the Earth. It's generated by fission reactions. And if you drill down and you pump water down there, you can heat your water up, pull it back up. You've got a hot water supply. You can make steam from it if you go down deep enough, rotate a turbine. If you got enough money to spend to run pipes through your floor before you pour your cement, you can have nice hot water flowing through your floor that heats your house from the floor.
Isn't that what they were trying to move towards, the geothermal? When they trying to move towards that way?
Yeah, we're still trying to move towards that. Unfortunately, it's kind of more expensive to build, and not every place. Some places you got to go really deep to get to the heat. If you're in Wyoming near Yellowstone, the heat comes right up to the surface, so you've got the geysers and all that. So you don't have to go down very far. So certain places it's much cheaper to build geothermal than in other places. But nonetheless, those are not directly related to solar. And then you've got tidal energy. And that's really energy having to do with the rotation of the moon around the Earth. So that's, kind of call that gravitational. That's renewable. So that's a general overview of all of the forms of energy, all the sources of energy that we'll be talking about. So now chapter 19 is focusing just on these three. And then we're going to move and consider the other ones. But like I say, underlying all of this is the second law of thermodynamics. Anytime you go from one to another, you're losing a certain amount of energy. But this is basically our universe, yeah.
So nuclear is non-renewable and geothermal is renewable?
So nuclear is non-renewable because there's a finite amount of uranium in the Earth. We got a pretty good supply of it. Geothermal, we think the Earth hopefully will continue for a while, so that's considered renewable. Mars, they thought Mars had a core that was spinning inside the planet that stopped. So we think Mars is dead today because it ran out of that. It actually ran out of the magnet. The reason we have a magnetic field around the Earth is because our core is rotating, and you take iron and you rotate it and you create a magnetic field. And that's really valuable because that magnetic field blocks out a lot of the solar radiation that would basically fry our atmosphere and give us all cancer really quick. So we're really, we're dependent upon that core of the Earth rotating. You don't think of yourself being reliant on the core of the Earth, but what happens down there is very important. Isn't science cool? Okay, you guys. What's today? Thursday?
Yep.
Thursday, so quiz on Tuesday on this stuff in chapter 19. I would focus on what we went on in what we did in these classes, because I haven't really gotten into the meat of chapter 19 yet.
So what chapter was this, 17?
19.
This is chapter 9?
19. We went from 1 to 19. We're skipping ahead, and then we're going to start